All right, now the null factor law is about 0, okay, null for 0. So I want you to think about when we multiply by 0, what happens? Everything is 0. So if we've got 3 times 0, then that's 0. 0 times 5, a times 0, so whatever number is 0. You've got these really big digits. We still get 0 because there's a times 0, isn't there, in there? 0 times x is the same as a times 0. And what about if we had 0 times x plus 3? Still 0, right? Because you've still got a 0. Love 0. So if 2x is 0, then x must be 0. What about if we've got 2 things multiplied with an answer of 0? What can you tell me about them? One of them, at least one of them has to be 0, right? Potentially they could both be 0, but if they were 2 different values, at least one of them has to be 0. So we have to say that a equals 0 or b equals 0. Now I want you to think back up here. We had this idea of 2 solutions. Something equals something or something equals something else. And so that's not new to you. You've seen it now already. You've the potential of 2 possible solutions. One is 0 or the other. And that's what the null factor law is, actually. If 2 or more things are multiplied to give 0, at least one of them has to be 0. That's really what the null factor law is telling you, which should make sense to you, right? Yes? Yes, Mrs. Kondo, that makes sense. Okay, so then if we want to look at continuing with our solving, let's do that. Solve for these variables. So if we potentially look at this first one, which we've already really done, 3x equals 0. So 3 times a number equals 0. Even if we think about that idea of dividing by side by 3, we still, x has to be 0 because the 3's not. So it has to be the x that's 0. What about when we've got x times y equals 0? Yeah, so x equals 0 or y equals 0, or potentially both, but usually we just write x equals 0 or y equals 0. What about the next one? This time we've got x and we've got times x take 2 equals 0. So x is 0 or x take 2 equals 0, so in other words x equals 2. So again, we've now got 2 solutions. X is 0 or the x take 2 part is 0, which means x must be 2. And that's the null factor law. That's it, pretty much. So it's a bit like the squaring, same idea where you've got the option of 2 solutions, but with the null factor law, one of them has to be 0. So when we've got x take 2 and x plus 3, they represent 2 numbers multiplied together to give an answer of 0. So this is so in order for us to solve this, either that part has to be 0 or it's this part that has to be 0, one or the other, or both.
But I don't get why we solve something.
Well, this is just an equation to say I'm looking at 2 numbers that multiply to give 0. By the null factor law, one of them has to be 0. So for what value of x am I going to get one of those brackets equal to 0? If one of those numbers is 5, then this number is the one that has to be 0. Because 5 times 0 is the only way we're going to get 0. But if one of those numbers is, say, x take 2, then that potentially x take 2 could be 0, or if one of those numbers says x plus 3, then the other option would be x plus 3 equals 0. But one of them has to be 0.
Well, why do you have the other one now? Why do you have that bit?
Because that bit tells me what x is, because the aim of the game is to solve for x. So if I've got 2 things multiplied to give 0, I need you to tell me what is my value for x. I'm solving an equation here. What is my value for x that shows me that that equation equals 0? Does that help those that weren't sure?
I think I got it.
So one of those values has to be 0. We don't know which one. Potentially it could be x is 2, which would lead the first bracket to be 0, or x is -3. Now, this should look familiar to you because what do those two brackets represent? We've been spending time building up to this. Binomials. Yeah, they're two binomials. And when we multiply to give 0, what are we actually finding? It actually links quite nicely to our quadratic graphs. We're actually linking that. That's what we're doing. At the moment, we're just practicing the skill. But next time I see you, we're going to link this to the quadratic graphs if you haven't already picked out what that connection is. So for now, we're just practicing the skill. All right, so let's have a look at this one. So here we've got two options. Either x is 0, this bit, or this bit. Now, we've got a situation here where then we need to solve a little equation, an equation within an equation, essentially. Nothing you've done, nothing, this is a bit different. You haven't really done this before, that kind of equation within an equation. And then f is a bit trickier still because you've got two equations within the equation. Either that first bracket is 0 or the second bracket is 0. Either way, we've got two options for x. So we're solving for the aim, with all of these, we're essentially solving an equation. Now, you have spent lesson after lesson solving equations over the last few years, but every single equation pretty much that you've solved, apart from a few that we've extended you with this year, have been linear equations where there's only one solution. All linear equations pretty much have one solution or potentially none, but one solution essentially. This time we don't have a linear equation. These are actually quadratic equations. How do we know they're quadratic equations? Well, they're up to f at least. So when we expand the brackets, we're going to get the x squared term. That tells us the quadratic. G is actually not quadratic, it's cubic because there's 3 x's in there, but that's another story. We'll leave that for another time. But essentially the same thing. Each of those brackets represent 3 numbers. In order for that equation to equal 0, one of those 3 numbers has to be 0. And so we have to work out what x is to decide what one of those numbers might be. So x could be 8, because if we put 8 in there, we get 8 take 8, which is 0. Or, these ones aren't quite so nice. 2x equals 7, so x is 7 on 2. So if we put 7 on 2 or 3.5 in there, that second bracket, which represents a different number, could be 0. Or you've got your 5x plus 4, which is 0. So 5x equals -4 and x equals -4 fifths. Again, if I stick -4 fifths into there for x, that bracket, that bit, will be 0. It represents a number that is 0, which would make that whole equation equal to 0, regardless of what the other 2 brackets end up being. Yep.
In like a question like this, do you have to say which bracket will equal?
No, it's one or the other. We don't know. One or the other. So they're your options.
Yeah.
And h, well, we've got this 2, which is a constant. So it can't be 2 that equals 0. So it's got to be either the x plus 1 or the x take 8. So any of these which has 2 solutions like this actually pretty much represent quadratic equations. We could potentially have 2 solutions with a cubic, but that's, like I said, for another day. 2 solutions, quadratic equations, pretty much, particularly if they're in 2 brackets, binomial form. Okay, so how does it get harder?
Yes.
How does it get harder? Well, we've been practicing factorising, haven't we?
No.
Those double brackets, what if they're not? What if they're expanded? And this is going back to what Charlotte was saying, well, I could expand it. Yeah, you can. We can expand the bracket. We end up with a situation like this, where then we have to factorise to get to the answer. But it can be done. So these should look familiar to you.
Yeah, they're so nice.
You have to put the eggs on the house.
So we try and factorise. Yep, factorise out, taking out the highest common factor. And then if it's a trinomial, we factorise the trinomial by setting up our two brackets. You know the drill. We've done this up 10 times now. Not the solving part, but definitely the factorising part. The extra step here is the factorising, right? We've got the expanded form. One of the advantages of factorising is that it's much easier to solve in this kind of format. So from the expanded form, we factorise and now we can solve it. We can now solve this equation. Either x is 0 or this other number, the x take 5 is 0. So x is 5. Here, first thing we do is factorise out the x as well. So again, you've got that common factor, x or the 4x take 3 is 0. So again, two solutions. What about the next one? How do we factorise our quadratic?
Trinomial.
It's a trinomial. The others are quadratics as well, but not formal trinomials. But this is a trinomial. So it's just extending all that practice we've done. Two numbers, multiply to give 2, add to give 3. They are 2 and 1. So once we set up our trinomial, factorise it, again we can solve x plus 2 equals 0 or x plus 1 equals 0. Two solutions, -2 or -1. So if I put those two values back into my original trinomial, if I put in -2, I'll get an answer of 0. If I put in -1, I'll get an answer of 0 as well. There's two solutions. And that's what back up here was kind of all about, the fact that you could have two solutions to a problem. And how does this relate to the trinomial stuff that we're doing? Well, if I subtract both sides by 25, I've got now a solution equal to 0. How do I factorise that x squared take 25? How do I factorise that? Do we know? Does that come, it's a difference of?
Dots.
It's a dot, it's a difference of 2 squares. How do I factorise a dots? Don't I do x take 5 and x plus 5 equals 0?
Yes.
And so, if we solve x take 5 equals 0 or x plus 5 equals 0, don't I have x equals 5 or x equals -5? Same deal. Right, so that's how we make that connection. So Charlotte, you're back here. Let's see if we can answer your question. Can we expand it? We sure can. So if we expand this out, we get x squared, take 6x plus 9. Sorry, not equals 0. Whoops, that's a mistake. Equals 49. So let's take 49 and we get take 40 equals 0. And then we've got x take 10, x, hopefully you can see where we're going here, equals 0. And so x is 10 or x is -4. So we get to the same point.
Where did it take 6x?
Take 6x comes from the expansion of x take 3 all squared. So if we set up the two brackets, x squared, take 3x, take 3x plus 9. So the 2 take 3x's is what gives you the take 6x there. So yeah, it can be done using expanding as well. So the point is, more than one solution to equations. You've never seen that before, really. And then we're going to connect it to all the work we've done on quadratics.
Is there going to be double dots?
Wait,
Is there going to be double dots?
then why is there not like
Potentially we could get double dots. Yeah. So x plus 7, x plus 7 and, whoops, that's wrong. Sorry, my apologies. It is x, two numbers that multiply to give 15. and add to give 8. X plus 3 and x plus 5 equals 0. So x equals negative 3 or x equals negative 5. Here, this tricked a few of you, but it's a take 10 and a plus 3. Negative 10 times positive 3 is negative 30. Negative 10 plus 3. Negative 10 plus 3 is equal to negative 7. So again, x take 10 equals 0 or x plus 3 equals 0. So x equals 10 or x equals negative 3. This one's a dots. So you've got a plus 3 and a take 3. So x plus 3 equals 0 or x take 3 equals 0. X is negative 3 or x equals positive 3. To be perfectly honest, when we started looking at these types of questions, we did a plus 9 and then did our square roots. This is actually a better system. This one, highest common factor, what is it? When we do this one, 3 has to come out first. And so then we've got two numbers that multiply to give negative 11. Add to give 10. So x take 1 equals 0 or x plus 11 equals 0. So x is negative 11 or x equals 1. There are two solutions. H is the challenge and so too J. So I'll leave you to think about those. With I, once you've got that take 14 equals 0, it's now just a standard trinomial that you need to factorise. Two numbers that multiply to give negative 14 and add to give 5. So then x equals 2 or x equals negative 7. So going back to these ones, if you get really stuck, I'll give you a hint.
Can you give us a hint?
Now, we've already tried them. Okay, only because there's a couple of minutes left. All right, if I'll give you a hint, let's try grouping. But with the grouping, we need to split this. That's my hint to you. Split that negative 5x and try and group it.
How do you do?
You can't do the trinomials the way I've shown you because of that too. It's not a mono.
Trinomial. Because I just did it by trinomial.
Yeah, you can do it by trying it. How do you do it? You have to split. Well, there's a couple of methods, but one method is to split and try and group it. So, for example, if I were to split this, I could suggest maybe a take 4x, take x plus 2. And there's my two groups.
Oh, yeah.
We could group that pair and group that pair. So we would take out a 2x. And then we could take out a negative x take 2. And so you've got x take 2 and 2x take 1. So they're more challenging.
Is that the answer?
Not yet. We still haven't finished because we're solving for 0, right? So we still need our 0 solution. So x take 2 equals 0 or 2x take 1 equals 0. Now, we haven't done those formally, but that is one method of tackling those kinds of problems.
Would that be
So that's getting a bit beyond where we're ready. So what I want to see from you is to be able to do ones like I and G. Now, Year 9, it is very important that we continue to practice this work. There's lots of questions there that looks like a whole heap, but some of them you'll be able to knock off quite quickly. So over the next day or so, and tomorrow we'll do a bit more consolidation, I want you to spend 15 minutes on that tonight. I'll be checking 15 minutes on that tonight. And then we'll spend a bit more time after a bit of consolidation tomorrow on some of those questions as well. Okay?